Hi, this is Josh from Over the Shoulder Coding, and today we're going to tackle day 4 of the Advent of Code 2018 challenge. So for day 4, you've sneaked into another supply closet. This time it's across from the prototype suite manufacturing lab. You need to sneak inside and fix the issues with the suit, but there's a guard stationed outside the lab, so this is as close as you can safely get. As you search the closet for anything that might help, you discover that you're not the first person to want to sneak in. Covering the walls, someone has spent an hour starting every midnight for the past few months secretly observing this guard post. They've been writing down the ID of the one guard on duty that night. The elves seem to have decided that one guard was enough for the overnight shift, as well as when they fall asleep or wake up while at their post. Your puzzle input. For example, consider the following records, which have already been organized into chronological order. On November 1st at midnight, the guard 10 begins the shift. Then at 5 minutes in, falls asleep. At 25 minutes in, wakes up. 30 minutes in, falls asleep. 55-minute wakes up. Then the next day, 2 minutes before midnight, guard number 99 begins a shift. Then falls asleep. Then wakes up. Then guard 10 begins a shift. Then falls asleep, wakes up. Then guard 99, and guard 99 on the next day. So timestamps are written using year, month, day, hour, minute format. The guard falling asleep or waking up is always the one whose shift most recently started. Because all asleep awake times are during the midnight hour, only the minute portion is relevant for those events. Visually, these records show that the guards are asleep at these times. The columns are date, which show the month, day portion of the relevant day. ID, which shows the guard on duty that day, and minute, which shows the minute during which the guard was asleep during the midnight hour. Awake is the dot, and asleep is the pound sign. So for that first row, guard 10 falls asleep 5 minutes in, so it's, you know, 0, 1, 2, 3, 4 minutes, the guard is awake, and then the 5th minute, the guard is asleep, all the way until the guard wakes up at the 25th minute. If you can figure out the guard most likely to be asleep at a specific time, you might be able to trick that guard into working tonight so you can have the best chance of sneaking in. You have two strategies for choosing the best guard minute combination. Strategy 1. Find the guard that has the most minutes asleep. What minute does that guard spend asleep the most? In the example above, guard 10 spent the most minutes asleep, a total of 50 minutes, while guard 99 only spent for a total of 30 minutes. So guard 10 was asleep most and was asleep on both shifts during minute 24. While this example listed the entries in chronological order, your entries are in the order you found them. You'll need to organize them before they can be analyzed. So what is the ID of the guard you chose multiplied by the minute you chose? So guard 10 at minute 24 would be 240. So let's get our puzzle input. All right, so we have an unsorted list of year, month, date, hours, minute, and then what happens at that time. The guard wakes up, the guard falls asleep, or a different guard takes over. So one of the edge cases here was that this guard starts their shift before midnight. So they could fall asleep at like 23:59, at which this would start with asleep. So let's see if anything like that exists. 23 and then 50. Or is there any 40? So the earliest guard begins shift at the 46. So let's search for this date. And so then the guard starts asleep at the 0th minute. I don't know if the guard falls asleep before the 0th minute, but we can try and check really quickly. So let's look for 23 and a digit and another digit, bracket, guard, then some unknown number of digits, begins, lots of begins, but no falls asleep. So no guard falls asleep before midnight. All right, that's good. So we can avoid that edge case in here. We might need regex later. Let's begin with this input text over here. And we know we're probably going to have to use regex and date time. So let's see what we need to do. We need to sort all lines by the timestamp. So that's this time between the two brackets. It's a lot of lines. And then need to extract all the minutes and count when the guard was asleep or awake for all 60 minutes of that hour. Then we need to find guard that was asleep most. Find minute guard was asleep most. So it's pretty easy if we have a data structure like this, and we can have the ID as the key and then an array of length 60 of the minutes as the value. So we'll make a hash map of the guard ID to the minutes that the guard was asleep, and we'll also keep track of how many minutes the guard was asleep. That way we can find the minute from the array that the guard was asleep the most after we find, based on absolute count, which a guard was asleep the most. So we need to sort, and then we need it to track All right, so if we haven't seen the guard before, we're just going to make an integer array of size 60 and then put it in the dictionary. I guess we don't need a default dict because we can't optimize for it in any way, but maybe we can keep it around in case. So the key, card ID, and the value is counter array of minutes sleep. And we also want a guard sleep time map equals this to make our computation slightly easier. Don't have to sum the array at the end. Okay, so we're going to need to sort the lines. And to do that, we will need a method to extract the timestamp from a line. So we want to search between the two brackets. I'm pretty sure this is the right regex, but I will double check it. Cool. So the first group we get is this. Let's see if we can get the timestamp result from line 1. Great, so we can get it. Now we need to make a timestamp. Of year. I think it's month, date, and hour, minute. Let's get the date first. See if we're getting the right date. We are getting the right date. Let's check the time. That's correct. So we'll get a timestamp, which is going to be float. Then we can sort based on this. So we can sort the lines based on that. So we will make our sorted lines our unsorted lines based on extraction of lambda x, where comparator is the extracted timestamp. So let's print first sorted line, see what we get. So on January 28th at midnight, guard 151 begins the shift. Seems right to me. Most of these are later months, but let's just do a quick search. 15/18/01, 29/30, 28, nothing before 28. So quick search looks good to me. Could totally be wrong. We get our sorted lines, and then we make our dictionary to keep track, and then we're going to loop over all sorted lines. So for line in sorted lines, we need a guard number. So guard ID. If the part after is guard blah 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 begin shift, then we need to set the new guard ID. Otherwise, if guard falls asleep, or wake up, we need to update what happens at that point in time. I wonder if any guards stay asleep at the end here so that the new guard needs to update the old guard's time. Well, here the guard falls asleep. Guard 3539 wakes up before he falls asleep. Okay, well, let's ignore the edge case for now. We might have to come back to it. So let's search for guard blah 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 begin shift. We need some guard numbers. If we have a guard result that's not none, we will do something about it. So let's see what happens. Let's just try it. $71. All 71. So I'm not searching correctly. Let's test out this regex on our input. We're really getting nothing. So I found something with that, but nothing with this. That's the correct regex. See what we find. Okay. Find a bunch of guard IDs, starting with 151 first. If we get a new guard, we're going to say the guard is not asleep. Otherwise, if we don't get a new guard, we're going to check for whether falls asleep happens or wakes up happens. So guard, if it's not a new guard, we need to know the minute number. We can copy this. So the minutes after the colon, it's 2 digits for the closing bracket. Just test it out really quickly. So we get 5 minutes, this first and next line. So we're doing that correctly. So then we can say minute equals extract minute from the line. We need to know the last minute the guard was asleep. I guess we'll always need that, right? So if the guard falls asleep, you don't have to do anything, really. We can print it. So we need to get the guard sleep count map. The guard ID. And from the last minute that we had, which the guard woke up or we switched to new guard, to this minute, or if they wake up, they were asleep before. So from the last minute they were asleep to this minute, we need to set sleep array equal none. Need a array of size 60 and sleep. So we'll count the number of minutes they were asleep as well as incrementing the sleep array by 1. And then incrementing the guard's sleep time by the minutes the guard was asleep. So we don't need this guard asleep Boolean because we're just checking between the time the guard was asleep and awake. We extracted all the minutes and counted we need to find the guard that was asleep the most. We want to find the maximum value of guard's sleep time map. We want to find we're going to find the guard that was asleep for the most minutes if the sleep time for that guard was greater than the max sleep time we've seen so far, which is 0. We're going to set the sleepiest guard to that guard ID, and we'll print it out here. All right. So we're getting an empty or none object. I'm trying to get a key on that, and that wasn't working. So the sleepiest guard is guard 2081. Was asleep for 273 minutes. All right, let's find the sleepiest guard's sleepiest time. Oh, actually, 1459 was greater. Let's try it. So guard sleep array doesn't have a key. Guard 409 was asleep the most, so that is pretty weird. Definitely should. So increment the guard sleep time by that. Got it. We're never setting the guard sleep array back into the map. Let's try that now. Sleepiest guard, then print the sleep array. So it looks like guard is asleep for this 15 out of 15 times. So 59, 58, 57, 56, 55, 54, 53, 52, 51. Should be minute 51. Line range. We're going to find the sleepiest minute. So times sleep is going to be sleep array I if times asleep greater than most times asleep so far. Most times asleep is going to equal times asleep, and the sleepiest minute is going to equal that minute I. So guard 409 is sleepiest at minute 51. 409 times 51. Hmm, Make sure they're integers. 2859. So let's try that out as the answer. All right, that's the right answer. We got one gold star. And let's try part two. So part two of all guards, which guard is most frequently asleep on the same minute? An example, guard 99 spent minute 45 asleep more than any other guard or minute. So what is the ID of the guard you choose multiplied by the minute you choose? Got it. So instead of finding the sleepiest guard, we want to find the minute that the guard is asleep the most. Which guard is asleep the most at a certain minute, and find that. So we know that we sort the lines and do all this computation together. So we can move that into some pre-processing. We can share that between part one and part two. For part two, we just want the guard sleep array map, and we're going to find the sleepiest minute of the sleepiest guard. So for sleep array in guard sleep array map dot items, I guess we'll also grab this just to complete the return. So we're going to do a similar thing to what we did here to find the sleepiest minute of the guard, but we're going to do it across all guards. So for each guard and the guard sleep array, we're going to loop over all the minutes that the guard was asleep and see how many times the guard was asleep at that minute. If the times asleep the guard was asleep at that minute is greater than the most times asleep we've seen for all guards so far, we're going to save that. We're going to save that target guard that we want to use and then save the minute that the guard was asleep. Then at the end, we're going to print our output, which is the guard ID and the minute that the guard was asleep. So we want to print guard number blah was most asleep at minute blah. Let's try part 2. And let's delete our lines. So guard 2393 was asleep 32 times, or most asleep at line 32, with the answer 7,576. Let's try that. All right, we got that too. So we solved part 1 and part 2, and the way we did that was by first we sorted the lines, then for all lines we extracted the minutes, and we saw if it was a new guard, then we'd set the guard ID to be the new guard ID, so we could record that. And then in our dictionary of guard asleep map and guard sleep time, when the guard wakes up or woke up, we recorded the minutes that the guard was asleep, which was between the last minute that we saw when the guard fell asleep and the current minute. So we added that total time to the total minutes asleep, and we set the times the guard was asleep to be plus equals 1 in that sleep array, where we're recording the count of the guard asleep, which is basically, we go back to day 4, we're doing a count of this. So we're adding this to this line, and this would be 2 instead of pound sign. And then for 99, we'd be adding these 3 lines. So this would be 3, and this would be 2, and then this would be 1 in that array. So when we have that array in part 1, and we have the sum, we found the guard based on the sum that was asleep the most, and then we found the minute that that guard was asleep the most. And in part 2, we found the number of the highest number of times a guard was asleep at any given minute, and then returned that. So if you like this video, please give it a thumbs up and subscribe to my channel so you can know when I do the next video. And please support me on Patreon if you get a chance. Thanks, and I'll see you next time.